Hello everyone, we are students from group Argo alias from section 2. In this video, we would like to present about our project which named AI-based system to recommend the best travel route and times. Let us introduce about my group member and myself first. My name is Eng Yemi, and the other group member is Muhammad Edi and Harif.
My name is Muhammad Adi Usdan, and I will present about the background and the early analysis of the project. The project is about solving the problem the travelers face when identify the most efficient travel routes, and we want to use several factors in the formula to determine the best route. So the formula will be using 4 factors. The first factor is real-time traffic level, road congestion data, and weather condition factor, and also the user preferences, which is, for example, scenic or cheapest. And this is the formula that will be using the factor in the calculation. For early analysis, we have identified and understand the problem that the existing system cannot react dynamically to the sudden road congestion or weather changes in the location, and existing system cannot offer reliable routes based on calculation in real time. So we have decided to use the AI-based system to determine the best travel route and times. This is the problem analysis chart of the project. In the data given will be the input from the user, such as the current location and destination, and also we have the required result that will be printed in the last part of the system. For the processing required, we need to determine the high, moderate or low of the factors, and also we can take into the account user preferences such as the speed factor and determine the best route score. And also the PSC will also calculate and process the weather delay of the user. In the next part is the interactivity chart. We have 5 modules. The first one is read module. It have 6 modules from the read module, and after that we have the calculation module. We have the 5 sub-module of the calculation module, and the other calculation module for best route score A and B, and also the print module for 7 module that will be processed to print the output of the system and calculation. The next one is input processing output IPO. In IPO we have the input, processing and modular reference, and output. Input is the processing of the user input and the variable that will store the input, and in the processing we take from the algorithm to process the assigned value and determine the best route. In the module reference, we set some of the process to print or read or calculate. All this process will be determine the best score route and will be displayed in the output. Also, the system will output the prompt for the user to enter high, moderate or low for the weighted factors to calculate the formula. And the system will determine the recommended route, which is route A or route B in the simulation, and print out the delay or all other variables. So that's all for the part. The next part will be presented by Eng Yanbing.
Let's move to the algorithm part. The algorithm part starts by initializing all required variables and assigning all custom values. The system will proceed to the user input sections where the user is required to enter the current location, destination, budget limit, preferred departure time, and user preference factors such as speed, cost, safety, skinning. Then it will convert into numerical values which used to calculate the overall user preference score. After that, the system will calculate the best route score for both route A and route B. The route with the smaller values will be recommended by the system as it indicates better travel conditions. And if the weather conditions is considered poor, the system will prompt the users to decide whether to delay the travel schedule. Finally, the important information about the travel will be output. Now, let's move to the flowchart part. The flowchart begins with the start symbols and followed by a process to assign and all the constant value used. The user input are collected. Then including travel details and preference factors. Multiple decision symbols are used to validate the input, such as the speed, cost, safety, and scanning preference. If any input is invalid, the flow will return to the input step until valid data is entered. After that, the decisions and process symbol are used to convert the preference factor strings into numerical values. Next, calculation process will carry out to compute the real-time traffic level, route conjunctions data, and best route score for each route. Decision symbols is then used to compare both the best route scores and the system will output the recommended route based on the lower score. Another decision symbol will check the severity of weather conditions. And finally, the system will output the final travel details. Let's move to the part of algorithm with module. In this part, it follows the original algorithm and the interactivity chart presented in the previous slides. In this control modules design, the system is divided into 5 main modules, which is the read module, the calculate module, print module, and the modules for best route score A and best route score B. Both the best route score modules perform the same calculation logic but are applied to different routes. The read modules are responsible for calculating and validating all users' input. The calculate module handles the conversions of user preference strings into numerical values and thus calculate the overall user preference score. The print modules are responsible for displaying important travel information. Then the previous algorithm with module will present in a clear graphical representation in this flowchart. What you can see now is the control module, and this is the read module, calculate for best route score module, print module, and this is the where for the read module, where for calculate module, where for print module. And also got other sub-module for the read module, calculate module, and the print module in the following.